Okay, so to repeat, we have an allocator that accepts 2 tasks at a time, and those 2 tasks can be of one of 3 types, either no task, type 1, or type 2. So then what happens next?
It decides where to put it.
Okay, decides where to put it. And so what when you say where to put it, what kind of choices do we have?
Station 0 or 1.
Station 0 or 1. So we have 2 stations, and again, if you want to change yours to have more than 2 stations, you can do that later, but right now we're going to say we have 2 stations. And the allocator, now one thing that I was not clear on, but your professor cleared it up for me, is your allocator does not have to be smart. It does not look at the tasks and say, okay, well, station 0 does this and station 1 does this, and to be the most efficient, I should send this kind of task to station 1 and this kind of task to station 0. You don't have to do that. It's actually not a very smart allocator. I mean, I guess if you wanted to put that in, you could, but that's not part of the project, and it's not what he wants you to spend your time on. All he wants you to do is to look and see if the station is available. And if the station is available, it will assign a task. And if it's not, it won't. And so there will be an input coming from the stations to the allocators, and that's called R. And I called them, for me, I called it R0 and R1. If you wanted to, you could make it a vectored signal where you just called it R, and it went R1 to 0, so you had R1 and R0. It doesn't really matter. To me, I'm all about laziness, and that was like 2 extra keystrokes, and then if you count, you don't have to hold down the shift, but it was 2 extra keystrokes, so I just went with R0 and R1. So it receives these, and R0 and R1 tell the allocator whether or not it's busy or not. And so if it's busy, then this would equal 0, so it's busy, it cannot accept a task, and 1, available, it can accept a task. Okay, so, and then the allocator looks to see if they're busy, and then decides what to send them. So it can send them, it could send to station 0, task 1, task 2, or nothing. And it could send to station 1, task 2, or nothing. I found it, for me, most convenient to always send something so that the station knew that it was time to. It didn't really, I guess it didn't really matter, but I decided that if it wasn't going to assign a task, to send it a task of type 0. Because that way it was always sending something. It was either sending I'm not giving you something new, or I'm giving you a type 1, or I'm giving you a type 2. I don't think you have to do it that way. I think there are probably lots of ways to do it, but that was the way that I thought about it. Okay, so we have an allocator, we have station 0, we have station 1. What else do we have to have in our project? Okay, we do need a clock. Yeah, we're gonna need a clock. I'll just put that out here. In the quick question, when you say always sending it something, how do you mean? Okay, Ethan, I am gonna answer that in just a second as soon as I talk about the clock for a minute. So, in a lot of your labs this semester, you've relied on the clock a lot, that you've used the clock to make a counter, and the counter kind of advanced by itself, and you were relying on the system clock, and you would divide it up. But for this project, unless you do one of the bonuses that uses more than one 7-segment display, you don't need to use the really fast clock. You're just using the button clock, that when you press the button, that tells it that's equivalent to a clock signal. So our clock here is really just going to be, your professor calls it the system clock. I call it the button clock, so that you're aware that what we're talking about is the external button. If you are on Zoom, if you can see my window right here, if you have that open, it's these external buttons right there. That's what we're going to use for the clock. Okay, so now back to always sending it something. So what I mean by that is there are different ways, to send things with a program, but we're going to have an allocator module. So you'll have an allocator module, and one of its outputs is going to be the task that it's going to send to the station. So I called mine, what did I call it? Output S0 task, station 0 task. Okay, so the allocator is going to look at the inputs, and it will come up with this output for S0 task, and S0 task could be 0, 1, or 2. And then I'm going to have a station 0, and one of its inputs is going to be S0 task. And so the output for the allocator becomes the input for station 0, and that's what I mean by sending it something. So was that the question you were asking, Ethan? Yeah, okay, good. All right. So now going back, I said, okay, so I said, I was asking what else we needed in our project, and we got the clock. Okay, what else do we need? Okay, those are really good ideas. Anybody online? Okay, so if you go back and look in your project.
Several different modes.
Okay, yeah, okay, so there's modes, so we need to put that in. For the default project, you only need to have 2 modes. You need to have your normal mode where it runs, and you need to have reset mode. So we need to have that. But I did not make either the clock or the mode a module. You might do it however you design it. I did not. But there was one other module that I did, and that other module that I did was the display module, because there's a piece of information that we haven't collected yet that we're supposed to collect, and that is we are supposed to keep track of how many tasks we have processed. And so I thought about it. The project does not say how to do this. And so my thinking on this was that every clock cycle, station 0 and station 1 would have an output that would say whether or not they completed a task or not. And this would just be a 0 or a 1. So I think I called them complete 0 and complete 1. And you need to just keep track of how many you have. And so you can just have a variable. I called mine count, and every clock cycle I added complete 0 and complete 1 to my count, and then I had a number, and then you display that number. You have your 7-segment display, and you have to you're supposed to keep track for numbers up to 15. So you would have 0, 1, 2, 3. Is that a 3? Or is that a backwards 3? That's a 3. 4, 5, 6, 7, 8, 9, and then for 10, 11, 12, 13, 14, you do hexadecimal symbols. So you would have A, and then you need a lowercase b, because an uppercase B would look like an 8, a C, and a lowercase d, because an uppercase D would look like a 0, an E, and an F, and then a lowercase g, because an uppercase G would look like a 6.
Aren't the G and the 9 the same?
No, because you make your 9 with a straight line and the G like that. So I'm also curious what the rest mode does. Does it just set F and R to be 1 or idle, or however you set it up? Okay, I'll get to that question in a second. So, so you did the 7-segment display in one of your labs, so you already have your LED codes for that. You don't have them for A, B, C, D, E, F, G, but I remembered, because I have spent a lot of time in this class, that in your textbook on page, I can't read the page 219 on the PDF, they have a nice LED list right there, so for lazy people like me, there it was. So, okay, so rest mode. So if I understand correctly about the rest mode, or the reset mode, all he said the reset mode is supposed to do, let me pull up the project. And you have some freedom with this, with the reset mode. So it's kind of nice, because you don't, there's not like just one right way to do it. So it says, reset mode. The inputs are ignored, the stations are all in the idle state, an F flag indicates no unassigned task, and the task count is displayed at 0. Oh, I'm glad I read that, and I need to change that on mine. I didn't do that part yet. So all the reset mode does is it sets your stations to be in whatever state you have. So the stations are going to be finite state machines. To set them to be whatever state you have as I'm not doing anything. That's how you're going to set them. You're going to reset your count to 0, and any task that's coming in, you don't do anything with it. Your allocator is either just sending 0 or not sending anything at all. So that is my understanding of what the reset mode is, and it also can be he says it can be synchronous or asynchronous. And what that means is you can either have it so that whenever you change your mode switches to go to reset mode, it immediately goes to reset mode, or you can have it do it on the positive edge of the clock. So you could either put it in one of your finite state machines and just have it, if mode equals 1, then do this, or you could just have it be just do it right away. So did that answer that question? Okay, good. All right, so now going back, and that reminds me about one more thing we didn't include is one more output for the allocator, and that is the allocator also has an output of F, because some of these tasks take more than one clock cycle. And so if the station is busy and the allocator is not able to assign one of the tasks, it's just supposed to output, hey, I couldn't assign something. You don't have to know what kind of task it was. You don't have to keep track of it. All you have to do is have an LED to say, hey, there was a switch set for me to assign something and I was not able to assign it. And that's what F is. So it's F is an output. It's going to be an LED, and it'll be lit if it's not able to assign something. So I thought that probably the best way to proceed from here, unless there are other questions or suggestions, is to think about what your modules should be and what your inputs and outputs for each module should be. And then if we have a little time, maybe talk some more about the logic. So any thoughts on that? Suggestions, comments? All right, well, let's get going then. Okay, so first you are going to want to have, and again, there is not just one right way to do this. There's never just one right way to do any kind of programming. So this is how I thought of it, and you know, I could be messing all of you up if I'm thinking about it wrong, so, but I hope not. So, so let's look at what modules we think we might have. So there's going to be a top module, and in that top module, what you're going to have, puzzled how to get the outputs between the modules. Yes, use a wire top, but okay, it's easier than you think. You don't actually have to wire them together. If you have in your top module, so this is, we'll do it right here, so I'll explain it right here. So in your top module, you will have, as your inputs will equal all your physical inputs, and your outputs will be your physical outputs. So this is going to be all your LEDs, your switches, and the 7-segment display. And also, oh, be careful about this. You need to make sure that you have the correct code, or the correct constraint for the button clock, and you'll find that in Lab 9. So that's important, because if you have the wrong code for that, it's not going to work. So Lab 9 will have the correct constraint for the button clock. Yeah?
So for the inputs, are we doing it with the switches?
Yes. So, yeah, okay. So you will have, for your basic design, you'll have 2 switches for the mode. Although for your basic design, you only have to have normal and reset. He wants you to use 2 switches for them in case you were going to do more. So you'll have 2 switches for the mode, and those are supposed to be the leftmost switches, I think. And then you will need, for the basic design, you only need to have 2 switches for task 1. If you want to do bonus, you could have up to 4 switches. I laid mine out, like in the project, he has this example for how to lay it out. And so where it's debug here, I had those 2 being mode, and then I skipped 2 because I'm not using station. I had these first 2 for task 1, and then the next 2 for task 2. So that's what I had. And then two switches for task 1, 2 switches for task 2. I know I still haven't gotten your answer about the wire, but I'm getting there. 2 switches for task 2, right. And then if you do bonus, you'll have more. You'll have 2 LEDs to display the mode. You'll have 2 LEDs to display task 2, 2 LEDs to display task 1. And then you'll have the rightmost LED is for F, so the rightmost LED is for F. And then you'll need to have at least the first 7 of your 7-segment display. I also include the decimal point. I put that one in. And you'll need to have your AN, your 4 AN constraints. Because if you remember, when you do the 7-segment display, you not only have to give it the LED string, the string for which LEDs you want lit up, you also have to tell it which display you want it to go to. If you remember, going way back when, AN equals 0111 puts it on the first display, and AN equals 1011 puts it on the second. So you have to give it both of those things. And then, I mean, as long as I'm talking about constraints, this is not going to be in your, well, it is in your top module, because you will have, your clock is also going to be an input. So you'll have your clock, that's going to be there too. And so just to give you an idea as to what it looks like. It looks like, did Vivado crash on my computer? Yeah, it did. I hope it's saved. Oh, please have saved. This is, let's see. Okay, so if you can see here, I've got, you know, the first bit is for the clock, and then I have some various, which are these? These are switches, some various switches. So switches for task 2, switches for task 1, switches for the mode, LEDs for the mode, and task 1 and task 2. This is some of my debugging, so you can ignore these right here. And then LED for F, and then the 7-segment display, and then the AN for whichever segment it is. So those are your constraints. Okay, so then back to the top module. What else you have in the top module? So you'll have those. And then I also put in my top module, just right there, since the LEDs for the mode just match what the switch is, I just had right there in my top module that my mode LED equaled my mode switch. You know, just get that, you know, because there wasn't any logic to be done there. That's just what it equaled. So I had that in my top module. And then you also are going to instantiate each of your other modules. So you are going to have allocator, and then you'll have your list of inputs and outputs. And you'll have station 0 with its inputs and outputs. These need to be in the same order that you define them. When you define your module, if you don't put them in the same order, it will not work. You need to have station 1 with your inputs and outputs, and your display with its inputs and outputs, and we'll go through and talk about what those need to be with this. And then so how do you send things from one module to another? Well, that's where your inputs and outputs for your top module were your physical inputs and outputs. Anything that is an input or an output for one of the modules that's not the top module is going to be a wire. So for instance, I called the thing that the allocator said was going to be the task for station 0, I called that S0 task. And so this is an out, for me, was an output for the allocator. It was an input for station 0, and it's a wire for top module. Now, it does not have to have the same name in all of them. What's important is where its position is in this parameter list, but I'm kind of lazy and I just use the same name. And so what I would do is in my top module is I would have wire, well, I'll show you. I would have okay, so you can see right here, I've got my list of, these are my inputs and outputs and what I named them. The S1 task and S0 task, those are not really going to be outputs. But then for your wires, these wires are things that are outputs for the modules, for one module, and an input for another module. And so for example, complete 0, complete 1. That is the output for the stations. So complete 0 is what I call the output for station 0 to say, hey, I completed something. And that's 1 if it completed something, 0 if it's not. It's an input for the display module because the display module is going to take that and add it to its count if it completed something. R0 and R1, those are outputs for the stations. They're the stations. The stations are saying whether they're ready or not, and it's an output for the stations. It's an for the allocator. So that's where you put it. So you put it here in this top module, and that's where it is. So did that get to your question about how to link together your modules? So complete 0 and complete 1, yes. Okay, so there seems to be, okay, again, I think people are putting too much thought into the counter because it doesn't, we've had some pretty complicated counters. This one, we're really just adding things up. So all I did for my counter was, and again, I haven't actually run this yet, so I could, who knows if it works, but all I did for my counter was in my display module. So in my display module, I have something that it's not an input or an output. It's just a wire. So it's wire, and it is a 4-bit binary number. Because I want it to roll over when it gets to 15, and then I have inputs for display. So my complete 0 and complete 1 are inputs, and what this was count, by the way, so I called it count, and all I did was I said count equals count plus complete 0 plus complete 1. And I did that on the always at positive edge clock. So always at positive edge clock, my count is going to equal whatever it was before plus complete 0 plus complete 1. And that way, if these completed a task, it'll add 1 to it. And then I had a case statement based on count. The case statement would pick one of my LEDs and display it. So that's how I think I did it. I may be sending out another stream of emails tomorrow to say forget everything I said because none of it works. But yeah. So does that answer your question about complete 0 and complete 1 and how I'm using them? Yeah, I think it's a good theory. I do like it as a theory. Okay, so that kind of talks about the display module. Since I'm there, let me go ahead and continue with the display module, and we'll talk about what our inputs and outputs are for the display module. So for display, I had as my input was going to be whatever you call, I don't know that complete 0 and complete 1 are good names, but I had my inputs are my variables saying whether station 0 completed a task and whether station 1 completed a task. And I just had it be 1 if they completed it and 0 if they didn't, and that way adding it did exactly what it needed to do. And so I just would add those to my value for count. And let's see what else. I also had my input was a clock, because I did want this to do this on the positive edge of the clock. I didn't want it adding these all the time, because if it added it all the time, it would just get to be, it would be adding all the time. I only wanted it to add once every clock cycle. So once every clock cycle, look and see, has a task been completed? Yes, let me add that. And my output was my 7-segment display and AN. And I don't know, because I haven't really done the reset yet. I don't know if I need to do something here to have it. I probably need to put something in here. I probably need to have mode as an input as well to make the count go back to 0 when the mode is at reset mode. I have not done that yet, but I probably should do that. So let me show you here. My big picture of how I did things, and maybe the elaborated design will help. Okay, so I won't move it. I'm trying to get this to where it all is inside the screen for what I'm recording as well. Okay, so if you look at this, it's going to be, let me grab it. I don't know if it's what it's supposed to look like or not. It's what mine looks like. Okay, so, what's that?
Looks like you have your task mode clock going in and
Yeah, I mean, to me, it looked like it was doing what it was supposed to be doing. So I've got the tasks right here are inputs into the allocator. They also are outputs to the LEDs, because I think you're supposed to show them on an LED. The mode right now, I don't have the mode completely, I don't have the mode done yet. The mode right now is just going to an LED. The clock is going to my station 0, station 1, allocator, and display. They're all using the clock because they all advance on the clock cycle. And then my stations, station 0 has an output R0 that goes to the allocator that says whether it's busy. Station 1 has an output R1 that goes to the allocator saying whether it's busy. And then the allocator outputs a task for station 0, and it outputs a task for station 1. These LEDs right here are just what I was using for debugging, so I can see what it thinks it's doing. It's not, you're not supposed to have that in your final one, I don't think. And then my display module right here is taking the inputs, the complete from my 2 stations, and then it's going to add that, and then it's going to make the display right there. So that is how I conceived of the project, and so that's, to me, it's, you know, that's what I did. So questions about that before we go back and like go continue adding in the inputs and outputs for the modules? All right. Okay, so now moving on to, I'm gonna be lazy. Okay, so we can see, yes. So my inputs and outputs for this display module were what I thought they were. Okay, and then for my allocator, this is what I thought I needed for my inputs and outputs. I thought I needed task 1 and task 2 as inputs. So in my top module, those are mapped by wires. No, they're not. They're just the switches. They're the switches in the top module. I have as inputs R0 and R1, which are wires in the top module, and the clock, which is a constraint. And then I have as my outputs the task it gives to station 0 and the task it gives to station 1, and as an output F, which says whether or not it has any errors. Okay, and then we also have our station modules, and you're going to want to have 2. I recommend that you have a module for each station, because the way they're going to act is going to be very different depending on how they process tasks, and that's the big part we haven't talked about yet that we're going to get to after we do these inputs and outputs. Okay, so your stations are going to have, your output is going to be whether it's ready. Its input is going to be what task it's received from the allocator, and then mode if you have to go to reset. Your input is going to be a clock. Your output is going to be whether or not it's completed something. And then it's a finite state machine. And so you need to be able to say what state it's going to be in. So you'll have whatever state it's in right now, and then you'll have the logic that'll tell you whatever the next state is going to be. And then I'll talk about these parameters in a minute. These are the states that I thought I needed for station 0, and I'll come back to that for a minute. So the parameters are not inputs or outputs, those are definitions of the state. And station 1 is going to be exactly the same, except it will have different states. But it will have R1, complete 1, S1 task, but other than that, it will be the same. Okay, so I've now talked about the setup, like what each module has as its inputs and outputs. I'd now like to talk about the states of the finite state machine for station 0 and station 1, unless there are more questions. Okay, so let's talk about how these stations work. So station 0, you are told that station 0, they both can accept tasks of type 1 and type 2. And station 0 for type 1 I think it takes 1 clock cycle and type 2 is 2 clock cycles. Can anyone verify that for me?
So type 1 is just 1 clock cycle.
Uh-huh.
For type 2, they want us to have it where on some inputs it does 1 and other inputs it does 2.
No, that's for the bonus.
I don't think so.
I'm not doing that.
Because it says, so it has idle, and then it has type 1, and then it has type 2 1 and type 2 2.
No, those are the two different stations.
Okay, is that what it is?
Yeah. Let me make sure that I got it.
It says, type 2 task runs for 2 clock cycles. So you either run it on the first clock cycle or the second clock cycle.
Right. So what this is saying is type 1 completes in 1 clock cycle and type 2 completes in 2 clock cycles.
Type 2 is for both.
For station 0,
I'm just looking at the simple schedule part. You might be farther than that.
this is your actual project requirement. Yeah, the simple scheduler is different.
Okay.
Yeah, it is different. Yeah, and I went over this. We talked about it after class of the. So I'm pretty sure I understand what's going on here. So type 1 takes 1 clock cycle and type 2 takes 2 clock cycles. If you were his state machine, yes. So, well, not really type 1, well, yeah, kind of. Those are states. So these are the way I saw the states. Now, it's a little bit different than in the simple scheduler because there was one extra piece of information you needed to know. Not just was it ready, but did it complete a task? So I had my first state, so state 0 is ready and idle. And so what that would mean, if it's ready and idle, that means that R0, so this is just for station 0 because station 1 is different. R is 0, R0 is 1, it is ready, and it did not complete a task. But I'm not actually going to, so complete 0 equals 0. I'm not actually going to say whether it's ready. That is not going to be a more output because I want when the clock advances, I want it to tell the allocator whether it's ready on the next clock cycle. And so whether it's ready on the next clock cycle is going to depend on where it goes from here. So the completed is a more output, but the ready is a mealy output. You'll see what I mean by that in a minute. So right now we'll just talk about the complete 0 for state 0 is 0. And then I'll have state 1. State 1 is where it's ready, but it had just completed something. So complete 0 equals 1. So it's on state 0 means this is my last step of a process. And then I'll have state 2 means that I am on the first, oh, a heart. That was cool. How did that happen? I'll never repeat that in a million years. Okay, so state 2 means that it's in the first step of a 2-step cycle. So that means it did not complete. So complete 0 equals 0. It did not complete, and it's not going to be ready. Okay, so let's do a little bit more work with this. I'll draw my state diagram. So 0. So this is state 0. I called mine ready. That's supposed to say ready. This is going to be last step, and this will be first step. Okay, so if you're ready, then if you're in this step, then your complete output is 0. If you're in the last step, your complete output is 1. If you're in your first step, your complete output is 0. Now, where do you go depends on what your input is. So your input can be of type 0, 1, or 2. So if you are in ready and you get a type 0, you go back to ready, and so you get, if task 0 is 0, you get 0, and R0 is going to equal 1 because you will be ready. If you are in state 0 and you get type 1, you're going to go here, so you get type 1, and you'll be ready on the next clock cycle because it only takes 1 clock cycle. So you received a task 1, and R0 will equal 1. If you get task 2, you'll go here, and R0 will equal 0 because you're not going to be ready on the next clock cycle because this one has another step before it can go.
Can I ask a question?
Yes,
So it can receive either 0, 1, or 2?
it can receive 0, 1, or 2, yes.
So that's the task type?
That's the task type.
So in 0 means no task?
0 means no task.
But if you have on the basis 3 more, like, you have the option of like 0, 1, or 2, but at default it's 0, right?
Right. Well, or 0, it's 0 at 0. So you have 2 switches, and if they're both a 0, then it's type 0. And if you have this switch is on, that's 0, 1 would be type 1, 1, 0 would be type 2, and 1, 1 is don't care.
Do you even have to have a 0, 0?
It made my life easier, and the reason why I wanted to have it is I wanted to be able to say what happens on each step. I mean, I need every step of the clock cycle to do something. And so so for me, I've wanted that 0, 0. So I can envision a way of doing it without it, but I think it's easier to have it.
It's easier to kind of see what it does.
I think so too. It's because on each clock cycle, I have to have a mechanism for going from the first step of my 2-step cycle to the second step, even if it gets 0 inputs. So let's say that it is on the first step of a 2-step clock cycle, and the next time around, the tasks are 0. It still needs to move along. It still needs to go on. So I want it to always receive something and always process. So that's the way I thought of it. Okay, so that was the 3 inputs. If you're in the idle state, your 3 possibilities are: you return to the idle state, you go to the state where you say, I'm going to be done after the next one, or you go to the state that says, I've got another clock cycle to go. If you're in state 1, if you receive a 0, you go back to the idle state. If you receive a 1, you go back to this state. And if you receive a 2, you go to this state. Now, if you receive a 0, then you're ready. So R0 would equal 1. If you receive a 1, then you're ready. R0 would equal 1. But if you receive a 2, then R0 is going to equal 0 because you're not ready. Now, those are your 3 options if you're in state 1. If you're in state 2, you don't have any options. The only thing you can do is go to this state where you are going to complete your task in the next clock cycle. And so it doesn't matter what it receives. Now, it should receive a 0 because the allocator should say, you're busy, I can't give you a new task. And so it should receive a 0. But regardless, it doesn't matter. It needs to go here. And so, so this would be, and then, so this is, no matter what, it'll go here. But it should report that it'll be ready when it goes there, because when it goes there, its next one will be available. Now, I seem to have lost my Zoom chat. But I don't think anybody has asked anything. Okay, so that was my logic for station 0. Station 1 has very similar logic. Station 1, the only difference is you'll have 0, 1, 2, and 3. So 0, 1, 2, 3. For station 1, you have type 0, you have task of type 1, which takes 3 clock cycles. Type 2 takes 1 clock cycle. So if you're in state 0 and you get a 0, you go back here. If you get a 1, you go to here. If you get a 2, you go here. If you are in state 1 and you get a 0, you'd go here. If you're in state 1 and you get a 2, you get a 1, you go here. And if you get a 2, you go back to yourself. If you're in state 3, you don't have a choice, you go to 2. If you're in 2, you don't have a choice, you go to 1. And from here, this is station 1, R0 would equal 0, it's not ready. R1 would equal 0, it's not ready. Every other time, well, and then here, R1 would equal 0, it's not ready. And R1 would equal 0, it's not ready. Every other time it would be ready on the next clock cycle.
This is just your way of extending the clock cycles, right?
Yes. Yep. And so the way I implemented this in Verilog was exactly the way you implemented your Verilog in Lab 9. So the way you're going to do it is you'll have one always block. So I had an always block, so always at, and then depending on which station I was in, so task station 0. So always at task station 0, and then I had a case, and the case was based on my state, and so I had my 3 states here, and then for each state, so like state ready, I had what my complete was, so complete 0 equals 1, and then I had some if statements. So if I think I did another case statement. I did a case statement inside a case statement based on task S0. I'll just show you. So I'm not going to show you everything because you do need to do some work yourself, but and I also don't know if it works. Okay, so this is inside my station 0, and I have always at S0 task, and then I had a case statement, so based on whatever state my station 0 was in, and then here's my first case. I'm in my idle state. So if I'm in my idle state, I set complete equal to 0, and then I have another case statement based on what task it received. So it received a task 0. Then I said my next state is my idle state. R0 is 1. If I receive task 1, my next state is what I called in task 1 step. I'm ridiculous with variable names. In task 1 step. So that's state 1. So that was the one that it received a task that took 1 clock cycle. And because it would only take 1 clock cycle, it would be ready. So R0 is 1. And then if it received type 2, then it'd be in task 2 step. That's what I called that state. And R0 would be 0 because it would not be ready. And then I put a default because with a 2-bit binary number, there are 4 possibilities, and I have, the other one is a don't care. So I just made it say, okay, it shouldn't ever get here, but if it does, I said made it go to ready equals to ready 0. And then, so that's one always block, and then you'll have another always block for what actually happens on the clock edge. And then I have one more thing to talk about, and then I have to go study for a big test I have tomorrow. Okay, so inside the station 0 and station 1, you'll have, I decided at the last minute to make my reset synchronous, that do it on the edge of a clock. You could do it somewhere else. So this should have been if mode equals 0. So if mode equals 0, then to send, okay. So if mode equals 0, it would send it to the idle state. Otherwise, it's going to make the state equal to the next state. So that's generally how our finite state machines work. Okay, so the last bit of logic you need to think about is your allocator. And remember, your allocator doesn't need to be smart, but it needs to be a little smart. It needs to, if a station is busy, the way I interpreted it was if the station was busy, it sent it a task type 0. And that way the station just went on. If it was busy, that would tell it that I need to just move along in my states. So we'll talk about the allocator next, unless there are questions. Let me see. Oh, wait. Oh, hold on. State machine for the stations, where the task type defines. He told me to use a state machine. So in station 1, it takes. Oh, okay. He did talk about that. I don't know. If you want to try it that way, you can. Yeah. I can imagine that I can see that it would work. I have not thought about it, so I don't really know how it would work. I don't know. If you want me, if you want me to look at your code, I can do that, but I can't before Wednesday because I have to study for an exam. Let me see. So the task type defines an integer that the counter will count down from. Oh, I see. Yeah. No, I don't see an issue with that. So that's another way of doing things, that rather than rather than having it do a melee output the way I did, this suggestion is that you have a different output for the stations that just counts down, and when it gets to, rather than having the output come from whatever the input is, it just sends to the allocator when it's ready. So that would be another way of doing it. So yeah, I don't see any issue with that. It's a different way of doing it, and it sounds good to me.
Can you explain that again?
What time is it? I can. Okay, yeah. All right. So here's. Okay, so ready. I can't explain it quickly. It would require you to have another module that is a modulo 3 counter or a modulo 2 counter, and basically the idea is that if you receive say a task that's a 3 clock cycle task, then once you receive that, then you have your counter, and you just count down, and so you would on the first clock cycle you would say not ready. On the second clock cycle you would say not ready, and on the third clock cycle you would say ready. And that would be separate from the stuff that I was showing. So it'd be a different way of saying whether you were ready or not. Okay. All right, good. All right, so the last thing I wanted to talk about was the allocator logic. And this is probably not the best way to do it. I'm just saying it, it's just first thing that came to me. So the first thing that came to me was I looked at my 2 tasks. If both tasks were 0, then send 0 to both stations. Seems easy enough. Okay, then if else, okay, so else, if they're not both 0, at least one of them is not 0. So else, if task 1 is not 0, then if station 0 is ready, I'm not gonna write this. Let me do a tree. So I'm just going to say it. I'm not going to write it. I'm too lazy. Okay. So let's say they're not both 0. Then one of the 2 is not 0. So let's say task 1 is not 0. So task 1 is not 0. So you'll check station 0. If station 0 is ready, then you assign that task to station 0. So if station 0 is ready, then you set S0 task equals task 1. If station 0 is not ready, you check to see if station 1 is ready. If station 1 is ready, so this station 0 is not ready, but station 1 is ready, then you set task station 1 equal to task 1. If station 1 is also not ready, then you set F equal to 1. Okay, so if task 1 is not 0, you do those things. Okay, else, if task 1 is not 0, then task 1 is 0, which means task 2 is not 0, because we knew at least one of them was not 0. So then I follow the same logic. So if task 1 is 0, then I do the same thing with task 2. I send it to station 0 if station 0 is ready. I I send it to station 0. If station 0 is not ready, I send it to station 1 if station 1 is ready. If neither station 0 nor station 1 is ready, then I set F equal to 1. Okay, and then we have that, so I actually did this not with not 0, but 0. I actually did if task 1 was 0, then I assigned task 2. And then if task 2 was 0, I assigned task 1. And then if neither one was 0, I just went through and looked at the possibilities. So it's just some if statements. You just have to look and see, you know, if station 0 is available, you send it something, and if it's not, you just have to look at the different possibilities, and that's going to be some logic for you to try to figure out. So I can help you with that if you need help with that later on. But I think the people here are starting to fall asleep. 2 of them are. The other 20 are wide awake and paying very close attention. So I am going to have to call it a day for now. I am in town over the break and will be available by Zoom if you want, wherever you are, if you want to work on it over the break. As you can see, there really is kind of a lot to do with this, and so if you put it off until after Thanksgiving, you won't finish. I mean, there's not enough time to do it all on Monday. I will be around on that Monday, and I will be in my office, and I will have the basis boards available if y'all want to come try it out on that. And I think that is it. Okay, questions? All right then. Well, I am going to call it a day. And hold on. Let's see. Let me stop this.
Are you doing an assignment for?
Oh, I think I can remember. I don't have a QR code because I changed the time so many times, but I've got a record from Zoom, and then I think I can remember the 3 of them.
So, is there any way that we could borrow a board and offer you something that's collateral?
Ah.